In this lesson, we are talking about sketching function graphs. And when you draw a graph without actual data, you're making a sketch. So we're going to make a sketch of the following situation. An athlete measures her pulse rate during a 50-minute workout. The workout includes a 10-minute warm-up period and a 5-minute cool-down period. Sketch and label a graph showing her pulse rate during her workout. So the warm-up period means that she is increasing her heart rate. And so that means that when we go to graph it, we will be increasing on the graph. The cool-down period means that she is decreasing her heart rate. It's slowing down. So that means that we're going to have a decreasing part of my graph. So we are ready to go ahead and sketch a graph. Again, the warm-up period was 10 minutes. The cool-down period was 5 minutes, and it was a 50-minute workout. So we're actually comparing her heart rate to time. So I'm going to make my intervals along my x-axis intervals of 5. Now my heart rate should not start at the origin, because that would mean my heart rate would be 0 and I would be dead. So we have to make it realistic, so our heart rate has to start above the origin somewhere. Now since we're doing a sketch, we don't really have to decide on an actual heart rate. We would just start somewhere along the y-axis that's in the positive region. And then remember that we are warming up for 10 minutes. So since my intervals along my x-axis are 5 minutes each, I'm going to figure out where this 10 minutes is, which is right here. And so my heart rate will increase from time equals 0 until time equals 10 minutes. So I'm just going to make an increasing interval there. And then once she warms up, her heart rate might increase a little bit, or it might stay constant depending on what kind of activity she's doing. So we'll say that she's doing some kind of an activity where it stays at a pretty constant rate. Her heart rate is pretty steady. And then it comes time for her to cool down, and she does a 5-minute cool down period. So again, I am looking right here at 45 minutes because she has a 5-minute cool down period. So I need to make my sketch go a little bit further over. And once it gets to 45, it's going to start decreasing. So I'm going to take this a little bit further. And then at 45 minutes, it goes down for 5 minutes. Now, if you are a really good athlete, you would cool down until you get close to where you started. So here's where I started. It's pretty close, but 5 minutes didn't take me all the way down. In this second example, you have an empty rain bucket in your yard to collect rainwater. Rain falls for 6 hours and then stops. After 5 hours, the rain begins again and lasts for 1 more hour. Sketch a graph to represent the volume of water in your bucket during this time. So the first thing I notice is that we're talking about 6 hours plus 5 hours plus another hour. So I need 12 total hours, but if I look at my x-axis, it only has 10 squares. So I'm going to count each square as 2 units instead of 1, so I can see the entire picture. So let's go ahead and write down that each square is 2 units. So that's 2, 4, 6, 8, 10, 12. So I'll just mark where 12 is. We're talking about hours here, so I'm going to label this hours. And then we're talking about volume of rain. So volume of rain is going to be my y-axis. So it says I start with an empty rain bucket. So that means my origin is going to be part of my graph. And rain falls for 6 hours and then stops. So I'm going to find where 6 hours is, which is right here. So it doesn't say how hard it's raining, so it's just, I'm going to say it's steadily raining, so it's going to go up in a relatively straight line for 6 hours. So I'll go ahead and graph that part. So that's 2, 4, 6 hours. And then it stops for 5 hours. So that means that unless my bucket has a hole in it, the amount of rain in it will stay the same for 5 hours. So I'm going to go straight across in a horizontal manner for 5 hours. So that's right in between 10 and 12 is 11 because I already started with 6 hours. And then it starts to rain again and lasts for another hour. So that means that from my end point there, it's going to go back up. And again, I don't know how much it's raining, so I can make that up as much as I want to. So you could have a much steeper graph than I do, and that's all the information that we're given. In this example, you are asked to match each verbal description with its corresponding graph. So we're going to answer the bullet questions or fill in the bullet questions down below and then make our decision after that. So part A says you leave home and ride your bicycle to the library, where you stay for a while doing research for your science report. Then you ride to your friend's house. Part B says you ride your bicycle home from soccer practice. On the way, you stop at your friend's house for a while and then go straight home. So take note of time is along both x-axes, so those are the same about the graphs. Distance from home are the y-axes, so those are the same about the graphs. So notice that one has a decreasing interval, a constant interval, and a decreasing, and the other is increasing, constant, and increasing again. So down here it says you can use what you know about increasing, decreasing, and constant intervals to decide. As you leave home, your distance from home increases. While you're at the library, your distance from home stays the same. And when you ride to your friend's house, your distance from home, it's not very clear, but it does increase if your friend lives farther away than the library is from your house. Now, since we are choosing between these two graphs, we know that it doesn't increase, then stay constant, and then decrease. So this means that when you go to your friend's house, they are farther from the library than, farther from your home than the library is. So then, let's go down to this next part. When you ride home from practice, your distance from home decreases. When you're stopped at your friend's house, your distance from home stays the same. And when you head home from your friend's house, your distance from home decreases. So that will help you figure out which graph goes with which scenario. So part A, you leave home and ride your bike to the library. So from distance from home increases. So that would be this one. So this graph represents A's scenario. And this graph up here represents B's scenario, because when you ride your bike home from soccer practice, the distance from home decreases. This last example, some students might argue about this a little bit, but we are going to assume that when you have a candle in your house, you sometimes burn it. So if you never ever burn a candle, then that third example would be reasonable. But this one says each graph describes the height of a candle over a certain period of time. Which graph is not a reasonable description for the situation? So again, the only way that 3, this one, would be reasonable is if the height stayed the same forever, which means you would never burn the candle. Now, yes, that's possible, but it's not reasonable. People have candles in their house to burn them. So the height of the candle over time should not stay the same. As you burn a candle, the height decreases. So this scenario is where you burn the candle until it no longer exists, so until it goes down all the way. This scenario here is where you don't burn it, and then you decide to burn your candle for a little bit, so the height of the candle goes down. Then you blow the candle out, so it remains at that height, and then you burn it again. You blow it out, it remains at that height, and then you light it again to burn it until it is all the way down and the wax has gone away. So, which graph is not reasonable? That would be 3, because assuming you buy a candle, you're going to burn it. So 3 is not reasonable.